Alrighty, we're all set up. So my name's Sev. I'm from a company called Eleks. We'll introduce ourselves in a second. Um, Thank you very much. It's going to be a tough act to follow. I started my career out actually as being both an electrical engineer and a computer scientist. It That's how old I am. It was actually the same major in Princeton. It was electrical engineering and computer science. And we did analog design, we did digital design, we built our own computers. I had one of the very, very, very first Apple computers, and we had to solder it together before we could program it. And it's interesting to see that things do come back. So we're now doing the same things that we did back then, although with much, much more interesting plug and play and nearly foolproof technology, so that what we're doing now wasn't even imaginable back then. So the topic I'm going to talk to you about is a little bit about how we develop IoT applications, work on device development, and specifically we're going to show a prototype of a artificially intelligent refrigerator. Not one that tells you what not to eat, but one that actually can interact with you as a shopping assistant. Thanks also to Microsoft for hosting us. We at Eleks are sort of agnostic in terms of platform, but we lean very heavily to Microsoft platforms. In fact, the example I'm going to have is going to have a couple Microsoft tools in it. So there's Lewis, Tizen, and bots, and we're using the Microsoft bot here in this example. It's a little bit about Eleks. We were founded in August of 1991. It's also the year that Ukraine was founded as a country that fled the Soviet Union. And what happened was there was a bunch of electrical engineers that were managing the power grid for the Soviet Union, which all of a sudden became 17 separate countries. And they didn't know what to do, but they decided that there might be a business in controlling power grids of each of the newly independent countries. So from day one, it's really been a company run by engineers, doing a lot of machine control, process control, sensing, and doing the things that today underpin the not just the electrical grid, but going down to wearables and other devices. We have 1,010 employees. We had about 1,000 last month. We're primarily in Ukraine and Poland, but we have offices around the world. And what we do is software product engineering services. So what that means is we build products for you, or we build pieces of products for you, or we build components, or we test components. So we have a number of different approaches, but fundamentally, we're a services company, and we provide services to a number of industries. IoT being sort of a horizontal that covers anything from retail to finance, agriculture. We're controlling tractors out in fields, transportation, logistics, manufacturing, supply chain, healthcare, lots of different applications, as well as smart home. And there the target is working with both vendors of smart devices and also services providers that are interested in using these smart devices to provide their own services. An example we're going to give is going to be essentially a supermarket interfacing to your smart refrigerator. The approach we use is really one that's agile. So we start with innovation. We do a lot of proofs of concept. We'll do a lot of prototyping. What we'll show today actually will be a prototype. We can't show you anything we do under contract. That's one of the downsides of being in the contract development or contract R&D business. Usually that goes into MVP, then goes into a full-blown life cycle release, and then you go into maintenance, and that's where you do, for example, DevOps and those kinds of things. So it really starts with R&D, then becomes much more of an agile team, and then ultimately it's a production team. Some of the awards we've won over the time, generally we're thought of as being highly innovative. Out of the 1,000+ employees, 93% of them are PhDs or masters plus. They like to tinker, so we allow employees to participate in what we call Eleks Labs. If you go to elexlabs.com, in addition to the example I show now, you can see a broad range. In the back, we have some one-pagers on some of the things we've done. I think we were the first, actually, like the day that Apple launched the Apple Watch, we had an app out that allowed you to control, start, and monitor your Tesla car. And that was, I think it was a lot more fun to develop than it was commercially successful. So, experiment here is really, we took a look at what's coming down the pike, and Samsung's Tizen platform, which is now running 50 million plus devices, ranging from smartphones to tablets, some things that blow up, is in September they're supposed to release Tizen version 4. And Tizen version 4 is going to come with a complete platform. You can do .NET applications. We'll go through the entire stack. And just looking at this, saying, well, we got to be able to do something with it. We're doing some commercial projects. That doesn't have to be a smart fridge. It could be really any smart appliance. But wouldn't it be nice if you could actually talk to your refrigerator and it could talk back to you, and you could reorder your milk or cereal or whatever it is. So that was a little prototype task that we got. The hardware that's in this Samsung is incredibly powerful and overkill. And plus you have a nice display, you have audio input and output. So you really have pretty much everything you need from a hardware perspective, and you have a platform. The question is, how do you make it speak, and how do you provide that artificial intelligence, that natural language interface? Good thing is, there are lots of tools that you can use. So we tinkered with a few of those. We came up with what we're about to present. So what else does this have? Cameras, speakers, mics, sensors. You can really leverage a lot of this technology. Oops. Yep.
Hi, I am your shopping bot. What would you like to buy?
I need some coffee.
Which of these products do you want?
Give me the second, please.
How many items do you need?
One item.
Kicking Horse Coffee has been added to your cart. Would you like to continue shopping or complete your order?
Let's continue shopping.
What else are you looking for?
I need some milk.
Which of these products do you want?
The first.
How many items do you need?
One item, please.
2% reduced fat organic milk has been added to your cart. Would you like to continue shopping or complete your order?
Complete my order.
Okay, so it doesn't seem very impressive And I thought it was actually really boring. And like, it's easy to do. Other people have done it. Everybody has an Alexa or Siri or some kind of thing. But then you say, well, let's peel the onion and see what we did and what we had to piece together to make this happen. I said, oh, that's actually kind of cool. So first of all, it's running on a Tizen. So that's, right now we're using the 3.0 version. And here we're using an emulator since it's not out on actual devices. That's going to be the 4.0 version in September. And then we picked Xamarin.Forms. Reason for Xamarin was portability. So we'll go through, there are a number of stacks you can use, but with Xamarin, I can develop it once, and then I can port it onto iOS, I can port it onto Android, I can port it into Windows. So that's another kind of benefit, that I can make this app portable. Tizen has a number of APIs. It has text-to-speech, has speech-to-text, has a number of components, and I'll show you a more detailed diagram. Most importantly, it runs .NET. So I can do all my .NET type development and run it on the fridge. In fact, the only part that I may not want to have on the fridge is the shopping cart. I can keep the shopping cart on the fridge, or I can have that remote at a supermarket's e-commerce site and just use APIs to load this in. So that for us was, wow, that's kind of a cool thing to do. And then we used the Microsoft Bot framework to develop the interactive piece of it. The bot itself provides a lot of functionality, except it doesn't provide the actual AI. For the AI, we use Lewis. Lewis, also a Microsoft product, language understanding intelligent service. And it's tightly integrated with the Microsoft Bot. It's also comes standard, and you can deploy all of this, provision it in Azure, which is another advantage. So it's easy to get the whole stack sort of pre-configured. Feel free to ask questions, actually, if you have any questions. So what's interesting? So connects a lot of these multiple technologies, puts them, I think, in a slightly different use case. It's no longer client-server based purely. It's now doing most of the processing right in front of you. You could imagine having this distributed in your smart coffee maker, your smart pasta machine, your smart dishwasher. All these smart devices could interact with you and then dump or even be pre-programmed with reordered and stocking levels and automatically put that into your shopping carts. Because it runs locally, it also may be a little bit more resilient. So if you have one device down, or if your network's temporarily down, or you don't have internet connectivity, you might still be able to do these things. Shopping cart can be local, it could be remote, or it could be local and then shadowed at your e-commerce provider. The Xamarin gives us that cross-platform, particularly useful for the prototyping phase, and the testing phase initially, because I can then take this app and then run it on different platforms. For a full-blown UI experience, you're actually going to want to do the UI natively, but the business code would be common across, or at least 95% common. Bot server platform being provisioned on Azure, as well as Lewis. All of these are interchangeable. The advantage here was that it was pre-configured, easily provisionable. We could have done this on AWS. but would have required us to deploy a VM on AWS to run the stack. So if I go sort of step by step, from the user, there's a voice request that goes to the application. So that's the client level application that does the speech to text. That text string gets passed to the bot. The bot then interrogates Lewis, says, what does this mean? Lewis comes back with an intent and some actions or objects. So then that comes back to the bot that says, oh, I better do something with this. And it will execute some procedures there. Either present that back to the user, go back to the client. Client's now going to do text to speech, as well as displaying it on the screen. Or I can go, for example, if I say I want milk, now here it goes out and does an API to a product database, a call to a product database through an API, and says, return a list of different brands of milk, including images that are in stock that I can fulfill an order. And then that gets passed back to the bot, who passes it to the application to display. So the bot does a lot of the work, but the AI is really largely in the Lewis. Other tools we used the Prism framework, now drilling down one more level, really to create code that's much more maintainable and well-behaved, well-structured, because after all, this was a prototype, but we follow the same procedures as we do for developing client code, and you want all the good kinds of things that you do to have a well-structured, you want to have a well-structured app. So you want to do well-designed design patterns, have a well-structured XAML application, have the model view model topology, dependency injection, which is necessary to have sort of clean, stable code. Event aggregator, we use containers here, a Unity IOC container, which was specifically to support the dependency injection. What that means is pulling out the things out of each module that are likely to change and creating another bit of external code that's much more maintainable. So as you switch hardware, you switch APIs, it's easy to modify and port. Development platform was one thing. Then the installation environment included the Xamarin, Visual Studio, specifically the Tizen preview, the Tizen emulator, and their MI-based debugger. Also, to make all this work, we needed a GetForce, a powerful video card. The Tizen stack, so there are actually three ways that we could have done this. We chose to do the leftmost, so the highlighted ones. We really wanted to make it portable, so we wanted a .NET application. Here we're using C#, common language interface for our application development, and also for our code execution. There we're running Xamarin Forms, which is, as I mentioned earlier, is portable, and the platform-specific APIs specifically for this smart fridge. Beneath that, everything's on top of the standard .NET API, .NET runtime, and then you got your lower level stuff. This could also be done in the middle. This could be done with the native apps, or it could also be done as web apps. Tizen allows you to build these applications using Xamarin Forms and easily create a user interface, at least at the prototype stage. So we're expecting that we can actually show this on a real live refrigerator with some additional training in terms of the intents and so on come September. You can't do it on existing platforms because it doesn't support .NET. As I mentioned, you could use other stacks. We could use C++, or we could use the server-side web apps, but either of those topologies would be specific and would not be portable. Within Tizen, a bunch of APIs. We do the text-to-speech, the speech-to-text, the multimedia, security, location. All of that is now available. So knowing where you are is fed into the bot, and it's fed into the entire user experience there. Tizen can be run on a range of platforms. I think they have currently more than 50 million out there. Anything from wearables all the way to smart TVs, mobile devices, tablets, etc. Also can run on Raspberry Pi, which we just talked about. So here's where we use the bot framework. So essentially, there's the interaction between the user represented with the client app is chatting with the bot, then the bot's chatting to Lewis and back. So the process flow goes from various different actions. These can be done in any order. These are based on what Lewis calls intents. So these are things like, I want a product, identify a product, I want to pick something off a list, I want a quantity, I want a size, I want to check out. So for each of those, you would actually program in or train Lewis to recognize that, and then program the bot to have the appropriate actions. Bot and Lewis work very tightly. It took absolutely no setup time. Stability was very, very high. The flexibility is incredible. Essentially, you're passing back JSON objects, which can handle pretty much any kind of attributes, any kind of data. We can pass videos, we can pass images, we can pass links, we can pass strings, etc. The actions that the bot can handle are limited by only your imagination. That's essentially anything that's a procedure can be executed. So it's various APIs, it can be calling databases, it could be putting things into a shopping cart, it could be, you could even have the e-commerce done locally, although one wonders why, what the use case might be there. Finally, we get to Lewis, neural net based, self-improving. You program it or you train it. Essentially, what you do is you create intents. So here, the main intents we had were things like get product category, get product ordinal, which one, get product name, get product count, get product size, checkout, those kinds of intents. And then you train Lewis to recognize various different strings, phrases, sort of focusing on both words as well as on syntax. The more you train, the better it understands, like any machine learning. So intents and entities get returned to you via JSON strings. And that will have, for example, get product category, the name of the category, and then some other additional attributes. So there might be a % confidence that you've actually got it right, various other control parameters that will likely be passed. Really, that's where about 90% of the work comes in, is training. So it's no different than developing any application. You start with building your user stories. You flesh those out. You look at here, the commercial implementation would inevitably involve a lot of end user testing, coming up with different scenarios. How would you interact? What kinds of chats, et cetera. The baseline is actually the easy one. It's handling the exceptions. Oh, that's out of stock. What size do you want? I don't understand. If you say, which milk do you want? I want the red one. Hey, now I need to understand attributes of the product list like color. That's a whole lot more training. So as you come up with these scenarios, the more scenarios you come up with, the more user stories, the more complex the training, and eventually what seemed to be like a really, really simple flowchart now takes up walls and walls. So that's what you'd see in a commercial implementation, is a lot of effort into engineering that. Then the training becomes somewhat just a question of throwing bodies at it, having enough different people doing extensive testing that underpins each of these user stories. The magic really is coming up with all the different intents. And that's the example. What we have here, we have some handouts in the back. The slides are available at this URL. You can look at a lot more of our examples on elexlabs.com. I'd encourage you to do so. And if any of you ever either have questions or have any potential work that you need done, be absolutely delighted to chat. Questions? I know it's late, but thanks very much.
Great. Thanks, Sev. Okay. Well, thanks again for coming out, everybody. And we will see you next month.